Game Hi, good morning. I'm audible.
Yes, Vera.
Okay. Shall we
Yes, we are.
start? Shall we start or need to wait for anyone? So Dharma, shall we start?
Yes, Veera.
Okay, let's get started. So guys, in Kubernetes, few concepts are pending, especially, the Debian pod. So till now we discuss stateless applications. So we are taking Nginx image or HTTPD image, or directly, existing image you are calling from the ECR or Docker Hub. So these are stateless applications. Stateless applications are nothing but, so we have to deploy that stateless application images from the source code only. So inside this pod, there is no any data is going to be stored. In this case, this is completely stateless applications only. For example, let me share the screen. Yes, stateless applications. So stateless applications, if you create a service type is a load balancer, for example, your node is here. So inside two pods are running, even though, so service works under cluster level as we discussed. So for example, this is node 1, this is node 2. So here one pod is there, here one pod is there. So service is created under cluster, cluster level. So here ELB will create here, our node port also create here. So this will be rewrite like this. So the two parts are same application. Whatever, if you are created a Docker file, so image will be generated. The same image, if you are calling same image. So there is no problem here, especially the load balancer type send traffic to any pod. There is no problem here. The reason this is stateless application. Stateless application means, so this is source from, source for this application is any one of the image, Docker image, or, Docker image from, we are calling from Docker repository or Amazon ECR repository. So once we call that image, the inside image is same application. So whatever application we are deployed in this pod, both are same. So if the source and any user is accessing this load balancer, the request will go to any one of the application. There is no problem. The reason inside application is same. This is stateless application. So if I take one example here, the same example. So if I take a same example here, sorry. Okay, let me try. So stateful application is nothing but database kind of applications. So here, if you create a load balancer, for example, so here DB, two DBs are there. Let's an example. Two DBs are there like a stateless applications. This is stateful only. So once we configure this DB with a load balancer, and auto scaling. Sorry, load balance file. So here DB, let's say understand two DBs are there here. DB1, DB2. So the request is coming. Control C, Control V. The request is coming from the stateless application to DB. So here, if I consider three-tier architecture, so the DB is going to give a response to your application. This is two-tier only, so you can draw one more layer here for the three-tier. So here, if you can see, this is also LB, this is also LB. Let's an example. So my user is, okay, my user is, for example, here adding some records. Adding means sign up. So this is Flipkart application, just understand. If I give sign up means if I add my details, the request will go to application load balancer. Application is redirecting into database load balancer. So the request will go to any one of the DB, right? Here or here. So the customer user details stored here only. So now after, I mean, couple of days or tomorrow after, so today if I create an account, tomorrow I'm going to log in by giving my details. So again, the request will go to this load balancer. So load balancer and the traffic, any one of the server, any one of the server or pod, whatever this is. So this is VM or pod or container, physical server, cloud server, whatever it is. Just understand it. Process is same. If it is a VM, directly application runs on VM. If it is a pod, means on top of the VM, multiple pods will run in the form of applications. So the request will go to any one of the pod or any one of the instance. If you consider instance, this is instance. So the request will redirect to load balancer. So this load balancer also redirect this request to any one of the DB, like here also any one of the application, any one of the server. Same the load balancer send traffic to, for example, this DB. What will happen? The details are stored this DB only, not this DB, right? So immediately it will give an error, no details found. So again, this user is going to store the details. I have already given details. Why it is coming like that? Okay, anyway, let me sign up the details. So again, is going to give the details. Next time the request will go to again here. Your details are already stored. So the problem is data inconsistency. The data inconsistency is raised here for the stateful applications. So this is stateless. This is stateful. So this is stateless. No need to maintain state of your pod or instance. So the request will go to any node, any pod, same application will be there. But here it's not like that. This is storage. Database is nothing but storage. If a user is sign up, user is given details and sign up means the details are going to be stored any one of the DB. Next time, if he is going to access, the request has to go same DB. Understand? Otherwise, data inconsistency. So always here data is different, here data is different. If you maintain it multiple databases, here data is different, here data is different. Finally, user and some conflicts will come. Sometimes request is coming, sometimes request is not coming. So in this case, what we can understand, first of all, we are not supposed to use load balancer concept in database end. This is completely not recommended. Okay. Load balancer process is not at all recommended. So here, we have to create a directly database, only one database, not for multiple databases. So this database directly connected to your application. Okay, so this database directly connected to your application without any load balancer and auto scaling concepts. The reason the data is going to store, we have to maintain the state directly. So this is DB now. Okay, this is main DB. So here, this is my main DB, always primary DB, only one DB. So whenever user can access now, always the request will go to same DB. If I sign up, my details are going to store here. If I sign in, my request is going to here only, not multiple DBs. Now always records are going to store here only. But in this case, we have to understand one important thing here. Okay, the primary DB, we have only one DB. In this case, okay, in this case, so in this case, how to get high availability concepts? So as we understand here, if we have a load balancer, if any server may fail, so the load balancer is redirect request to one more server. So either here or here. But now the process is here completely different. So in the stateless applications, the data is not going to be stored, right? But in database applications, database kind of things, the data is going to be stored. So for example, if I create a load balancer here, definitely what will happen here? The request will go to any one of the DB. So data inconsistency will rise here. The reason user can feel like my data sometimes coming, sometimes not coming. So in this case, how to overcome this here, this process, how to overcome? So simply we have to take care of only one thing here. So here the thing is we have to configure only one database only. Okay. So everyone maybe raise a doubt here. In this case, if I configure only one database, then how to achieve high availability concept? Okay, then how to get a high availability concept if I create only database? So in the RDS, in the database, we have a read replica concepts. Okay, we have a read replica concepts. So this read replica concepts, okay, so this read replica concepts help to maintain the data, replicate the data respect to nearby regions. So the read replica is nothing but, so whenever you can create a master DB, so we can create a read replicas nearby regions or same regions, nearby regions or same regions. For example, here one read replica, here one read replica I have created. So this is Mumbai region. So this is US region. This is Australia region. So read replicas create from master only, and even always sync with master. Read replicas always sync with the master. Whenever you can create a read replica from the master, so from the master means primary, whatever data is there in the whatever data is there in here. Okay. Just wait. Yeah. So whatever data is there inside the master, the same data will be updated inside read replica. And not only at the time of creation, even not only at the time of creation of read replica. So the read replica always sync with master. I mean, if any data has updated, automatically the same data will be updated in read replicas. So for example, in this case, for example, your master made down. So simply we can promote your read replica as a master so that we can easily maintain the disaster recovery and high availability. Okay. And in this case, what we can understand here, in this case, what we can understand here. So these read replicas, you can create any region, same region, other region. Same region means high availability across same region and high availability across different region. Depends on your creation of read replica. Okay. And even guys, even though the nearby Australia, if the request has to come from the Australia, the request has to come from Australia, for example. So no need to come primary DB, master DB. They can access from Australia also. From Australia, if you maintain the same application in Australia region also, so the request no need to come primary of Mumbai. So they can access from Australia also. But here the point is we need to understand they can access only, they not insert the records. They are not possible to insert the records. So read replica always read the data, not insert the data. But primary DB always read plus write. You can create a records, you can read the records. I mean, you can add the details, you can write the details. But read replica only read. So for example, now, if I create a records, so I mean, user is sign up here. With their details, user is giving some details here. Sign up time, the request will go to always write means primary only. So now whenever the record is updated, for example, record number 1, here updated means same record number 1 updated, read replicas also. The reason always read replicas sync with master. For example, if I delete a record or delete a record, that's an example. Delete user 1 details. Delete user 1 details. So the same records deleted here. Deleted user 1. So the respective records also deleted in read replica also. So deleted user 1. Created user 1, for example. Same records will be created read replicas. So in this case, what we need to understand here. So what we need to understand here, if like primary DB fail or whatever reason it is, this is down. So what we can do, you can promote read replica as a master. Okay, read replica as a master. So whatever the data is there in the master, same data is there in read replica also, right? So we can promote. Whenever you can promote, so these applications next time onwards next time onwards access this read replica only, not primary. Main DB already down or deleted. And if the read replica moves to primary area, so here this place is empty, right? Again, from this, we can create a read replica. Read replica promote as a master. Again, from the master, you can create a one more read replica. If the DB has deleted, master DB has deleted. So this is the process will work in real time. No load balancer we have to configure in the database before, like stateless applications. So this is stateful applications, not stateless applications. Okay, let me change here. So whatever EC2 instance, or container or pod, whatever it is. So database before we haven't created any load balancer type of actions. DB always one, master DB always one. We have a read replicas. That's it only. Clear or any questions? Clear. 3-tier means one more tier will come, web access, web tier to interact with the user. This is app tier. This is DB tier. So any questions? Why we are not going to store? Why we are not going to redirect load balancer to databases? Any questions?
Veera, can you explain the flow once again?
Which flow? Entire flow?
Yes, Veera.
Yeah. So what we can do here, simply take a 3-tier architecture. So I have already done a one project, guys. Please go through YouTube. My NPN project is the 3-tier application deployment, 3-tier application development and something. So I have already shared the link to you. 3-tier AWS architecture. Okay. Let me take. Okay. So if you can see, guys, here, this is 3-tier architecture. So web tier is directly interact to user. So like, for example, if I open a Flipkart, I can access web tier. So if I purchase some shopping or whatever, if I do some shopping here, the request will go to web to app, app to DB. For example, yeah. So for example, if I search this mobile, so if I search, give any filter Apple mobiles, so the request will go to Apple database. I mean, the Flipkart database, and it will give back to mobile phones details from the database. But this is interaction, user interaction, right? User interaction is nothing but here web layer. And whenever I click on the phone, the request is redirect into application. Here we are writing API methods, get method, put method, delete method. Okay, add method means we are going to add some records, sign up or cart details, whatever. Okay, delete details means if I delete any records from my end user, so the records are going to be deleted from your account from the database. For example, if I go for my cart, whenever you can log in, so your login inside the details will be stored into the database. If you do any shopping under your user, the details is going to be stored. If you delete or add or create in your, respect to Flipkart database. So the Flipkart database, the request is redirecting from the application layer. The very first layer is web layer, user interaction layer. If you click anything, the request is redirecting it to the application layer. Here we, the background, we have written the long programming languages, Python, Java, Node.js, whatever. So here the front end is Java, CSS, HTML, Angular. Those are front end languages. And DB, we have a MySQL. We have PostgreSQL, Oracle DB, MariaDB. We have different DBs, NoSQL, sorry, SQL databases, MySQL databases, relational databases. So whenever give the request, whenever you can access anything from the Flipkart, the request first go to web server, then application server, then database server. So if you can see web server, we have application load balancer, and applications are app tier, web tier, we have a load balancer and auto scaling group also. And app tier also we have a load balancer. The request will be redirect any one of the server here or here, here, here or here, here or here or here or here. The reason inside application is same. If it is EC2 instances, we already discussed in auto scaling group concept. These servers will be created through auto scaling. The source is launch template and AMI. So if you do any changes, again, we have to deploy new AMI and give the launch template, update the version. So that auto scaling group will be collect the information. Next resources will be created from the launch template. See, whatever server, if you can take all, see this server, this server, this server, this server having same application. So if application load balancer send the request to any server, no problem. The request may go to this server, the request may go to this server, the request may go to this server. Doesn't matter, no problem. And same thing, an application server also, application code only there inside Python code or Java code or whatever. So this inside also Python code, same Python code, same Python code, same Python code, same Python code. The request will send here also no problem. But the coming to the database, here the where we can store the data. If I maintain multiple databases here, 1, 2, 3, 4, for example, what will happen? If I use the load balancer here, if I hit the request from here, the request is redirected to web layer, app layer. So web layer, any one of the server, app layer, any one of the server. If I give multiple DBs, any one of the DB, but it is not right, right? DB always only one. If I maintain a multiple databases, maybe if I use a load balancer, your load balancer can redirect request to any one of the DB. If it is redirect any one of the DB, the data is not going to be consistent. The reason, maybe if I add the records this time, if I sign up my details, the request is going, my details are going to be stored database one. And if I try to sign in, the next time the request is going to database two. Database two will give my end there is no data, but I have already signed up, right? So what we need to understand, there are multiple DBs. Maybe the data is going to be redirect any one of the DB. If you maintain like that, finally, if you create a 5 DBs, no databases will be matched with the data. The different data is going to maintain. So that is not at all correct. For example, if I create my account, I'm able to access my account always. If I purchase iPhone, I'm able to access, I always see my card details. So sometimes I'm able to, sometimes I'm unable to see. It is not correct, right? So if you maintain multiple databases, the data may be go any one of the database. So finally, all DBs are not matched. So that's what here only one DB we are going to maintain, not no load balance. These applications inside we are configure RDS details. So always the request will come to web layer, application layer. As per the API method, the request is redirected into the RDS. I mean, Amazon database services RDS. So here, yeah. Now in this case, always 1 DB, right? The request will go to always only same DB. Delete or create or update, whatever the request will go to only same DB. But to maintain the high availability, if this DB may be deleted, one more DB is not there, right? To give a high availability concept, so we are going to create a read replicas concept in the databases. Those read replicas are not configured to application, not configured to any application. The read replicas always sync with master only. When any records will be updated master, always those records will updated read replicas. Master may deleted read replicas and also records may be deleted. Why we need to get read replicas? For example, master may down. So this application is redirecting to immediately read replicas, not master. I mean, how it will be redirected? First, you need to promote the read replica to master. Then only request is redirecting into master. I mean, read replica promoted as a master. So whenever read replica promoted as a master, here this place is empty, right? Again, you can create a read replica from the master. So read replica promotion is promoted as a master. From the master, you can create a read replica. This is a process we work in the real time. Is this clear now? Any questions?
Yes, Veera, it's clear.
So always maintain 1 DB only, not multiple DBs. We are not supposed to create any load balancer for DBs. The reason DB inside data is there. Request always map to same DB, not multiple DBs. Clear, guys? Okay. So let's get started here. We need to understand a very important thing here. Okay. The important thing is here. Yeah. So the important thing is RDS. So, okay, that's what we are focusing here now, database end. So already we have discussed pods, right? These application pods, 1, 2, 3, 4 are instances, 1, 2, 3, 4 pod services also we discussed. But coming to the DB, so we have to take a MySQL image directly from the Docker Hub and create a pod. That MySQL pod you have to configure from your stateless pod. So I'm going to take care of one project. So please attend the, I'm going to plan a one workshop coming classes. I mean, next week, I think. So please attend the workshop. You will get a better clarity. Day 1 to whatever we discussed till now, everything will be covered in that workshop. So you will get a better clarity. Even I'm going to show you the same concept here also, but anyway, just try to join that workshop. We are going to send a link in YouTube also, so that you just join that link so that you will get a better clarity. So I'm going to show you from the scratch again the concepts. Anyway, so okay, so we are discussing AWS here, right? AWS also offers the database. So the reason we have a RDS concept in Amazon. Amazon RDS. So RDS is nothing but relational database services. Amazon RDS is nothing but relational database services. So RDS offers multiple, okay, multiple engines. So those are MySQL, PostgreSQL. So MariaDB, different MariaDB, Oracle DB, etc. So it will support multiple DBs like this. I mean, this DB you can take on-premises DB or cloud DB, but we are discussing in cloud, right? We have to take a cloud DB. So the cloud DB services is RDS service. RDS will give the DB as a service. You can take any one of the DB from here. But the thing is here, if you create a DB, this is also server, right? DB also server only, DB server only, but we are unable to see this server if you create a MySQL database. The reason this is Amazon managed database. RDS is nothing but managed database. RDS is cloud managed, AWS managed service. So whenever you can create a database server, we're unable to see that server. The reason this is AWS managed service. So the server will be created in AWS and so everything they can manage. Simply we can, whatever options you require, you can enable it only. Okay. And we have one more option also, DB on EC2. DB on EC2 concept is what here? So the DB on EC2 concept is here. You can create one EC2 instance. On top of that, you can install a database, that is database DB on EC2. But this is not deep. So this is DB on EC2, everything in your control. Launch one server, install MySQL database. That is database server only. But this is what this instance is not in our control, directly managed by AWS. So always the recommended actions are for the databases are cloud managed database only, Azure MySQL, GCP cloud, GCP databases, Amazon RDSs. All are same process only, little differences only there. So let's get started now. So here, if I give RDS here, so what is database? Database is nothing but where we can store the data in the structured format. Okay, so this is the dashboard of RDS, guys. So here create database option is there. So if I go to create a database option, so we have a standard create, easy create. So go for standard create only to understand the process and all. So if I go for standard create, see, we are able to see multiple engines here. Aurora MySQL. Okay, we'll discuss later what is Aurora. So MySQL, MariaDB, Oracle, IBM, SQL Server, PostgreSQL. We have a 6 DB engines RDS is going to support any flavor, whatever you can create here. And one more thing is Aurora MySQL compatible. So Aurora MySQL is nothing but little advantages we can see. For example, if we select MySQL, so MySQL is the most popular open source database in the world. So MySQL on RDS offers the rich features. If you go for MySQL and EC2, we won't get rich features. If you go for MySQL and RDS, you will get rich features. So we will get a scaling, flexibility, whatever at all. So the DB supports 64 TB, the storage capacity. And the reason, if you understand, our EC2 also supports 64 TB only, size, volume. So this is also server only, but we are managed server you are taking. Managed server means, managed database server means this server is not available in our end. That is created in AWS AWS provider end, but we can access from there only. Okay. So we have a different type of volumes it is supporting. If you can see automatic backup option. So whenever you can take a RDS, no need to configure any backup services. By default, RDS is going to take care. So if you can see supports up to 15 read replicas, for instance. I mean, whenever I create a master DB, so I'm able to create a read replicas, 15 read replicas within a single region, cross region, 5 read replicas I'm able to create. Read replicas is nothing but what read replicas create from the master. Whatever data is there in the master, those data is going to be updated into the read replicas. Okay, let's go to here. I'm checking MySQL community here. And if you can go for production dev test creator, go for free tier only template. If you go for production environment, we can see multi-agent DB cluster, multi-agent DB instance, single DB instance. So these options enable for high availability concept. So I'm taking free tier. That's what these options are grayed out here. So DB instance identifier means DB name. So credentials. So for EC2 instance, we have a PEM file to log in. So, but the databases, we have a username and password. So I'm giving password here. Remember this password. So this password will use to connect the DB. So T2 micro, yes, 2 CPS, 1 GB is mandatory. Storage, the minimum value storage 20 GB for the RDS. So don't connect EC2 computer. If you want to set up any connection, see, as we discuss here, the 3-tier architecture, the server is going to be, application server is going to be connect RDS, right? If you want to enable any connection, we can connect to an EC2 instance computer services. So this server is going to be connect, or you simply don't connect. So we can connect by using MySQL client. Yeah, where exactly this DB has to be created. I'm selecting default VPC, but real time always this DB will runs on private subnets, not public subnets. DB always private, right? So that's what. But here I'm creating public, creating inside the public. I will tell you reason. So the reason I'm going to access this RDS from any one of the third-party tool like Workbench and PZ admin tools we have in the market. So with help of the tools, we can connect this RDS and we can connect, we can insert the data. If you're connecting that using different tools, definitely TV should be in enabled in public access. This is for testing purpose, but in real time, your application is going to be connect this database. So your application also private, DB also private, but all are working in same VPC. Internally connection is possible by with the help of private connection. Existing default security you can take, availability and just leave it. So these are the details only. So if I create, once again, I'm going to show you what options I have selected. So selected MySQL, you can read these points, advantages of MySQL. Or if you select Aurora MySQL, we'll get more advantages. So instead of 64 TB, 128 TB will get, but the process is same. Little configurations will get more configurations. Go for MySQL. Okay, so we have to give. This is also kind of easy to instance only, guys. The background server will be created. I'm choosing directly MySQL client. But if you create a EC2 instance, take a operating system and install MySQL on top of that. But directly I'm taking MySQL, managed RDS, right? So the background MySQL is to be installed in one instance. That instance is taken care by cloud providers. Already MySQL, empty MySQL instances are run. They are going to be handed to us. So retire, you just select here credentials. Next, just keep all the steps, storage and instance type. Instance type means RDS database instance type. Allocation storage, don't connect instance. Select network option. Same like EC2. All steps are same, but EC2 PEM file concept is there. In database, there is no, there is no, excuse me. In database, there is no PEM file concept, only username and password. But don't forget to enable public access to test the RDS from the external to connect to insert the tables and something. So that's what I have enabled public access. If we enable private access, we are unable to connect this RDS from the external tools. So like EC2 instance private means we are unable to connect by we can connect through bash and host, right? Same here also the process is same. We have to connect through bash and host otherwise. So if you are trying to directly connect, you enable the public access. But real time only private, not no public. So I'm creating RDS instance. This is the database I'm creating now. So my database, we can give configuration from simply your application. So please go through my AWS project. You will get better knowledge. YouTube, just go here. You can give Veerababu, just AWS Naresh IT. If you can give like this is the AWS project 3 tab. So 4 videos are there, total 4 videos. This is session 4. Entire project we have deployed in 3 sessions. 4th session we have deployed by using Terraform. Okay, if you go for the previous sessions here, okay, you can see here previous sessions also. Yeah, this is this is the first video. So here you can find this is video 1. So from here you can see the links, 2nd, 3rd, 4th videos also. So entire process we have explained. Okay. So for total 4 sessions, this is session 1, session 2, session 3, session 4. Complete the project. First 3 sessions is manually creation architecture. 4th session is through project. Okay. So please go through it. Same project I'm implementing through DevOps now. If you are interested, you just go through it. Just type in YouTube AWS 3-tier project Naresh IT. So first time, in the YouTube, nowhere is available 3-tier concepts. First time we have implemented. Just I'm saying that only. The same project again, I'm implementing a DevOps process. Like instead of deploying my application directly into the EC2 instance, what I can do, I will write a Docker file, create an image, create a pod. Instead of 8 instances, one instance instead I'm running in 8 pods. It will take time to create a cluster. I mean, cluster is nothing but this is RDS cluster. Inside RDS cluster, DB instance is running. This is DB instance. See, DB instance means EC2 server, but where this is server we are able to access from here, but this server actually running in AWS. This is AWS managed RDS. Backing up. So this DB, if I click this DB, so like EC2 instance, we have a public IP PEM file to connect, right? And port number is 22 SSH for Linux server. So here the DB MySQL DB port number is 3306. So in the EC2 instance, host name or endpoint, everything is public IP, but database endpoint is this one. Whenever you can create a database, the endpoint will be created. With the help of this endpoint only, we will connect. The same inside VPC, these subnets are created. I mean, my end already these subnets are there, right? So in this subnet, my DB is created in any one of the subnet. So this is, we are able to see read replicas. If you are going to create, we can create any one of the subnet. The list of subnets we can see inside the VPC. So my DB is running on this, these many subnet, this subnet group. This subnet group means contains these many subnets. So my DB is going to be share the things, any one of the subnet. Okay, this is active now, available now. So to connect the database, to insert the any data, so simply we are using tool is MySQL Workbench. So you can just download from the Google MySQL Workbench. Download. Download MySQL Workbench. MySQL will be down. Workbench will be downloaded. Just click on it. So just you can download. The tool will be downloaded into local. So you just open the tool and you can connect your database and start the inserting. Okay. Okay. So my end already installed. So this is my SQL. Whenever you can open the Workbench from the search, we're able to see this dashboard. And so click on this plus symbol. So here I have to give the connection name MySQL I'm giving. You can give any name, no problem, doesn't matter. So host name is nothing but your DB endpoint. So DB should be public, only you are able to access from external, otherwise not possible. You have to use a bash host server. From the server you can connect to run the one command. So root username is admin. So stored password means we have given one password, right? I have to give this password. Okay. So endpoint, password, username, and connection name, test connection. And your security group also should be enabled 3306. Otherwise, this connection may fail. 3306 port number. Otherwise, security group, whatever security group attached for the creation of RDS, the security group rule should be enabled 3306. Okay. Okay. So this is the connection. You can open now. Just ignore. Yeah. So this is the query editor, guys. Database only understands query language only, not like others language. So the database background DBMS software will work. The DBMS software will allow to run a queries on it, to execute the queries, to create a tables. So everything we have to create a databases under here. Inside my DB instances, I'm creating a one database. Create a database. So you just give the, create database test. If you give like this, one DB will be created inside that instance. So this just refresh here. So test I'm able to see. So usually tables will be created inside database only, right? So I'm going to create a table. So we can do one thing simply. We can go for any Google query tools, creation of tables. Creation of tables means create tables, select the database, and give the fields. Tables MySQL. So we have a website, 33 School. You can just follow this. So you just create a table here, the sample table. You can create anything, whatever. So I'm just taking this. I'm not going to insert any records, just creating a tables, empty table only, just for testing purpose only. As a DevOps engineers, we no need to create any tables and all. That is taken care by database engineers only. So test.persons means tables should be created in this test database only. Otherwise, it is not going to be created. Select and run means only this query will run. This query will ignore. Test already there, right? That's what we are ignoring. Okay. So just you can click here, tables information, persons table is created. So columns, this is the information. Okay, so if you want to perform multiple actions, you can just practice here query editor tool by using MySQL Workbench tool. So many tools are there. PG admin. So we have SQL management studio tool. So we can easily connect. So this is the process. And now what I'm going to do here. So for example, this is my DB, right? So if I create a read replica from my database, so read replica, what is read replica? Create a one replica, right? So this replica, you can create one more time. I'm showing you here, actions, read replica. So here, if I give here my read replica name, read. So here the same, see here destination region, we can create in same region, different region. So we give just take a different region, Mumbai. So Mumbai, same steps. I'm just like DB creation steps only, creating read replica in Mumbai region. So simply go for same credentials and everything is same. Okay. So here we have to understand read replicas are publicly accessible, and very important thing, guys, RDS is managed by AWS, right? So whatever things, if you require, just only select only. If required, for example, if you require any multi-aged DB. You just here click means you will get a multi-aged availability. If you click this, you will get multi-aged DB instance. Whatever option, these are high availability options. No need to configure anything externally. Everything is provided by AWS Manager Service. If you click, they will give a high availability across JZ, cluster level, instance level, whatever. So if I need backup, simply you can automatic backup is enabled. No need to configure anything. If you need a logs, click the logs. If you need a maintenance, something, whatever, these are just enabling. So just select the options, we'll get the respective actions. This is manager service. But if you want to do some actions, a DB on EC2, if you create an instance, if you configure DB, if you want to create a high availability concepts are very, very difficult here. DB and EC2, but RDS is simply we can take it. So I'm creating a read replica. So guys, whenever you can create a read replica from the master, whatever data is there in the master, everything will be updated inside the read replica. So it will take time, at least 10 to 15 minutes. So after read replica created in the Mumbai region, so let me switch to Mumbai region. So once we create a read replica, we can connect the read replica. So this is, you just ignore it. Read replica is creating here. So whenever you can create a read replica, endpoint will be created, same port number, same credentials. You can connect read replica, and if you can run a query, select star. I mean, if you can see the show databases, you are able to see tested database in read replica also. Mean data is replicating master to read replica. Okay, so this is I'm taking directly RDS DB, right? If it's a Dockerizing concept, what we need to do? Pod MySQL. See, I'm taking directly MySQL pod, but this is MySQL image. This image is coming from Docker Hub only. So I'm not going to develop any MySQL image. Inside nothing is there, right? Now application is not there. This is empty image. MySQL is empty image, right? Docker Hub. If you want to develop containerization application, so DB also containerization. You just type here. So Kubernetes pod will take MySQL from the Docker Hub. Any MySQL image it will take. So it will start the process. Taken directly MySQL image. But guys, in real time, front end and back end, we are using the containerization process. But a database, real time, most of the companies are not, taking containerization process of database, directly taking cloud manager database. The reason consistency, pods are very lightweight, right? So we are not supposed to depend on this. See, one stateless application pod deleted means nothing is there. One more pod will be created inside of the same application. But database pod is nothing but pod also store the data. Okay, that is very critical thing. That's what most of the companies, DB not follows the Dockerization process. DB follows directly RDS or on-premises database. Simply the endpoint username password they have to give into the stateless application pod inside. Pod will be connected directly. Okay, I will show you in the project how to connect. So clear, are any questions so far? So minimal listen. Here are any questions, guys?
Clear, Veera, no questions.
So anyone from DB background here? Any basics, you know? Anyone? Or everyone is new? Today only you are attending the class on DB? Any experience on DB?
No.
Not experience. You don't know DB till now, right? Oh, okay. Then I will do one.
Actually, I have an idea on that video. I
Okay, at
worked
least
on my
one
DB.
person know. Yeah, you guys are working closely, right? I think one person knows also we can share the knowledge. I will share to you one document. Yes, what you need to do here. Files. So MySQL document I have prepared from the scratch. That really very helpful to you to complete this task. Yeah, this one only. No, this one is a Word document. So Amazon Relational Database Service, the steps, what you need to configure, username, password, and download MySQL Workbench from this location. And after that, open your MySQL Workbench, install, and then connect, give the name, endpoint, username, and password, connect successfully, and connect here. Here you can run some sample queries. So we have given here the sample queries also. So you can just go through it if you're interested in queries to run. After that, creating read replica. Read replica is connected successfully. If I check in my read replica, the master DB also exists here. So this is the process. I will share this document. So any questions meanwhile? It is going to create. Any questions you can ask different topics also, no problem. Okay. So here our scope of work is to create a cluster only, not for creating a tables, schema models that is taken care by DB team. Just our part of the work is to create a cluster by using Terraform also. So if you're interested to create a this through Terraform, so you just go to here, Terraform repository. Here, if you can come my repository, you can find RDS project RDS. If you create by using Terraform, cluster will be created. So read replica also will be. Yeah, it is till it is taking time always. Very quick. Yeah, still creating. So once it will create the process is same. Take the endpoint, username and password. You can open new connection again. So you can open new connection again here. So here you just give again the endpoint. Yeah, configuring. I think now configuring master to read. I think complete in 2 minutes. Yeah, read replica is updated. Take the read replica. Still it is a configuring anyway. Just wait for a couple of minutes only, it will complete. Let's try to take anyway meanwhile. Still it is going on replica. Name you can give replica, no problem. I think this is updated. Control V. Same password. So give here replica MySQL, whatever name, and let's take the endpoint, modify. Yeah, let's take, no, we'll see. Read replica endpoint. The username is same, password also same like your master. Okay, test connection. Still it is modifying mode so that So it is taking time, I think. You can see here. So cross-region replica, it will take time more actually. We're supposed to create same region, but just testing purpose. But I have created in different regions, so that it is taking time. Okay, guys, just you can try your end. So if you are facing any issues to connect the read replica, let me know tomorrow. I will show you. But you just follow the document I have shared. So this is very clear document, the creation of read replicant and masters and all. So if you're facing any issues, let me know tomorrow. We can discuss. Is it fine?
Yes, Viran.
Yes.
Yeah. Same
Yes,
process,
Veera.
the connection. Whenever the status is active means just take the endpoint, same username password you can give here. But here, here we can see directly the table details. The test table we have created, right? We can see like that in this directly. Just taking time. That's what. Okay, guys. So that's all for today. Please go through that document if you're facing any issues. So tomorrow I'll show you one more time. Thank you. Bye bye.
Thank
Thank
you,
you.
Veera.
Thank you, Viran.
Yeah.